Good morning, guys. Hello, everyone. I'm Mr.Bellic, and in today's lecture, we are starting image segmentation. So, this is our second video of our computer vision playlist. Actually, not computer vision; it's like OpenCV. So, we are starting with a new video, and I have given introduction in previous video, and some uh, it's like a little bit weird English, but I'm learning, and let's go. So in this lecture, we will cover first what are contours, what is how to add our contours in our image, and what is the hierarchy of contour, etc. Okay. After that, I will teach you what is moment and how can we use moment for sorting, approximation, and matching. After this, we will detect line, circle, and blob in our images. I will also tell what is blob, although I know that you don't know. Many of you would know, but it's not so common. What is blob? Then in next video we will count the circle, ellipse in the videos, etc. Then in last video we will find the corners of the image. Okay, so let's start with our first chapter with contours. Okay. So first question is what is contours? So you as you can see that green circle here. Contours are there the circles which are surrounded the boxes which are surrounding the objects. Contours tell with the objects which we have to identify. The objects which are in an image. So let's start with the contours. Just I'm going to Google Colab. And with collab I have one more thing to show to you. Wait, there is my subscriber, you know very close to my heart. Where is the video? Yeah, so this is her comment. Playlist ball fit se. So this means she want me to say playlist again, so here it is. Playlist. Just kidding, guys. Let's continue with our video. So let's open our collab. uh, uh, this one. Just search collab. Okay, so if you are watching our channel with only this video and you have not watched previous videos, so tell you that we use collab for the coding part. And wait, it's loading. Yeah, it's like a Jupyter notebook and which give us GPU for work, so that low-end PC user can also do the computer vision or other deep learning codes. So let's rename it with name contours. Okay, contour. जो भी, I think you can say it. I just don't know correct pronunciation. So first step is like our old viewers should know, and for new viewers, first we will import some libraries. It's like first is computer vision. Second is NumPy, which we will use for mathematical analysis. Third is for plotting, matplotlib. And after that, we will we define some functions. The function which we define is IMSO. This function we use to show the image. So so first here W means width, H means heights. So first, wait, here some error. Yeah. So so image dot shape give 0 give us height, image dot shape 1 give us width. Okay. So aspect ratio is W by H, everyone knows it. Then we plot the figure, and then IMSO function shows the image. This is title, and this is to show the image. Okay. After this, we will download the images, which I will provide this link in the description. And this is the syntax to download the image, wget. Okay. After that, we will unzip our images. This is the syntax to unzip, and this is the name of image. You can see here image.zip. Let's run this cell. Uh, okay. So what are counters? Counters are the continuous lines of curve that bound or cover the full boundary of an object. It's like I have shown you before. These are the counter which cover all the boundaries of the object. For circle, this circle, for square, this circle. It's not always in the shape of circle or square. We will see in the lectures or chapters ahead. Okay. Let's go to Colab again. So our first step is to load the image. Okay. So first we will take a variable called image and we will set it with the cv2.imread function which read the image, and this image is here in the folder which we have just downloaded and zipped. Wait. Okay. There was some fault, indentation error. Yeah. Okay. So this is the image folder, and from which we have taken lp.jpg. Let me show you where is lp. So I just can't see where it is, but it is in this list only. Wait, I will show you how it look. Yeah, so it look like this. Although this image is so big, so we just add the size. Wait, let lower it. It's okay. Actually, now it's much smaller. Yeah. Now it is perfect. So we will wait. Yeah, we will find the counters of this image and wait. Okay. So we will use cv2.find counters to find the counter, and this will sorry consist these parameter. First is image, then is retrieval mode, then is approximation mode. For image is the variable in which image is stored. There are some retrieval mode, and this is some approximation mode. We will try each of these. First is retrieval list. This is used to retrieve all the counters but does not create any parent child. Parent child relationship is basically used for hierarchy. I will show you what are parent and kid. Wait, I will explain you what is this first. Yeah, so it's like this, that this is a counter which is inside this one, which is inside this one, which is inside this one. So this is the parent, and this is his child, and it's his child, its child, and so on. Like, wait, I will show you. So this is the parent counter. Wait, uh, I will make the counters. Then you will understand better. Oh, so our first step is make an variable image and read the image. After, our step is convert it to grayscale. Okay, So remember one very important thing, that if you are converting, you are making counters for an image like this. So you have to follow this step. First is load the image, then grayscale the image, then canny the image, then make contours of the image. Okay. Remember, load the image, grayscale the image, canny the image, make contour the image. You will get the perfect counter if you follow these 4 steps. Okay. What is canny, how to load, and what is grayscale, I have explained in previous video. If you have not seen, just go and check it out. Okay. So we make a variable gray in which we changes our color from RGB to BGR to gray. How we do that, I have told you in previous video. And then we will make a threshold value. Yeah, if I don't want to, if you don't want to can the image, you can put the threshold also. All it depend on the situation. You can use here canny also if you want, but it's some letters, so canny would not work so much here. So I use threshold. Although we will do it with canny afterwards. Next is using the counter function, which is new. Yeah, counters and hierarchy. CV2 CV2.find counter function. This function give us two things. One is list of a counters. How many counters are there? It give a list of counters, and hierarchy, parent-child relationship. Okay. So first parameter is, yeah. Okay. Sorry, I just got distracted. First parameter is the variable where the image is stored. From here you can see the th2, which is the image, and this is ret, which I have told you earlier. It just give an list that is the image is converted to threshold or not. Okay. We just we have to deal with th2. Okay. So th2 here, retr list is like retrieval mode, retrieval list. It will retrieve all the counter. Just don't make any relationship with the parent child. And what is chain approx none and chain approx simple? It's like chain approx null store all the points, and chain approx simple is just it store the endpoints. Like if this is one counter, then this to this, it will store only 2 points. But the chain approx null stores all the points here. Okay. So after we got the counter here, we will use draw counters function. cv2.draw counter. Here is the image on which we have to draw the counters, then counter the list of the counters, and here what -1 is, uh, uh, yeah. So -1 tells that we have to draw the counters on the image, and this is the color of the counter, and this is the, of course, thickness of the counter. Okay. Now as we have drawn the counter, we will show the image, and we will print the number of counter found. Let's go. Okay, so this is the original image, and this is the image with counters. You can see this is a counter, this is a counter, this is a counter, and this is parent, and this is child. You can see small counters inside. It is parent, this is child counters. So total 38 counters are found here. Okay. Um, and let me show you how these counters look. Uh, counters, counter 0. This will have first counter. Yeah, you can see this is a list of an array. which consists of this array of data type int32. This array have all the points of first counter, whichever first counter is counter 0. Okay, let's start. Okay, so first question is, what will happen if we do not threshold or Canada image? You should see it. Wait, let me show you. Change it to gray. Here, see, it will only have one counter. It can't, uh, you know, it does not have the counter information. It can't decide are the counters. So it's necessary to make an image to, canny or threshold it. And yes, if you are finding counters, always remember that your image should be in grayscale mode, cause in color mode, your counter would not be as good, give as good result as they will give as grayscale mode. And okay, so this is the same code like we have written here. Just there is one thing that we have made an edge with Kenny without thresholding it. So let's see how Kenny image will give us the result. So this is the Kenny image. You can see it's better than this. Okay. So we have found 77 counters. Here we have found what is happening. Oh, wait. TH. Here we have found 38 counters, and here we have found 77 counters. So you can see that how can image is got much more uh, counters here. So remember, use scanning method every time you use this. Now we will use different retrieval modes. First, we will use retrieval list. Okay. It retrieve all the counters, but does not create any. It does not create any relationship. But and every counter belong to same hierarchy level. Means this is also adult parent, and this is also parent. There is no relation between these two, although there is relation, but it will not make any relation. And list of everyone, so there will be number of counter would be 77 after this. So just copy the whole code here and paste it here. Okay. Oh, okay. So this one we are using threshold, so that we should learn first, then we should apply the can function, cause it have so many counters. So first we will go with some low amount of counters. Okay. Then our function is counter hierarchy. It's ext2.find counters. Here is the function which we are using, retrieval list. It will give all 38 counters according to me, and it will print hierarchy as well, 38. So it's hierarchy. It is in the form of 1 minus 1 minus 1 minus 1. What is 1 minus 1 minus 1? Of course, you would not know. Let me write here so that when you will see my code, you will understand what is this. Okay. So first term in index of the next counter. So this is the index of the next counter. It's 0 counter, so it's the index of next counter. Then second, then third, fourth. Okay. They are making 1 2 3 4 5 6 7 8 9 10 index of next counters. Second term is the index of previous counter. So it is one. Of course, minus 1 does not exist. It's 1, so it's 0, and it's third, then it's first. It is first. Okay. Index of parent counter. You can see there is no relation, so everything is minus 1 minus 1 minus 1 minus 1 minus 1. And this is the child counters, minus 1 minus 1, because there is no child and no parent, because it does not create any relation of child and parent. Okay, so this was all about retrieval list. Next is retrieval external. Wait, yeah, I am writing this all cause you can see just code or the Colab notebook, and you can know what is in the code just seeing by a notebook. Okay, so what is retrieval external? It is return only extreme outer flag. All child counters are left behind. Okay, so it will just, according to me, will consist of this, 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 and all the outside ones. Let's just copy the above code and paste here, and just here change it from list to external, and then run the code. Okay, you can see there is only 16 counters which have no connection of parent or child. Everyone is minus 1, because everyone is only parent. Child is not considered here. And this is second, and this one is previous. Okay, after this we will retrieval CCOMP. Look, what is this? It retrieve all the counters and arrange them to 2-level hierarchy. Okay, so let's see how it works. Just change here to retrieval comp. Okay, wait, image is so big. Let's make 2. Okay, it have all the counters and 2-level hierarchy. It's like it does not have any hierarchy. No child, no parent, no child, no parent, no parent. Oh, it have 11 parents. Sorry, 11th one is its parent. Okay, 11th index is parent, and it does not have any child. No parent, no parent, no parent, no parent. And it's child index is this 10 10 10 10 10 10 10. Same, it has parent at 18 index and no child. It has no parent, and 7 is its child, and so go on. Okay, so this was all about retrieval comp, and then we will come with retrieval tree. Okay, so what it did is just make an 2-level hierarchy, and what tree does is it make full family list, and how it creates, I will just show you. Yeah, I'm not explaining the code again because it's just same code which I have explained first above, and it's just some changes which I'm saying. It's like here we are making it retrieval tree, and all the code is same. uh, you can look this minus no child no parent, no child no parent, same. It's like here 11 -1 -1 10 18 -1. Wait, something will be different here. No. Okay, so it does not have anyone which have parent on child both. Okay, we will see further if any counters come here. So after this, all our retrieval mode have finished. Now let's see our uh, countering modes. The first one is chain approximation. It just give the all the points. Let's see. Same code, just we have here cv2 dot chain approximation. Here we have used retrieval mode as tree because it give all the points and all the hierarchy, and it also give all the points. Let's see, 38, and there are the points 87, 57. Length of the points, you know, in first it is 87 counter. First counter have 87 points, second counter has 50 points. Let's see, same code, just change here from approximation to approx. Simple. And I put a text here, control C. Okay, I have to write it in caps lock on. Just sorry for the mistake. Yeah, here you can see it has 87 points, and it have only 8 points because it only starting and ending points of the counters 8 10 7 1 1 1 1, and it is 7 57 then 1 1 1 1. Okay, till here there is the same code. What is different is that we just put this. It's like this will print the number of counter like above code, and this is foreseen the counters. So counter was a list of array, so it will count every array which we have in the list. So in list 0, list at 0 index has 87 arrays. and then 50, then 7, then 1, 1, 1, 1. Here is only 8. So you can see how less it is than simple, because it give only the uh, uh, starting and ending point of the counters. Okay, so I think this is all for this chapter, and let's open a new collab library. Just first save it and new notebook. Okay. Line, circle, blob. Okay. Mm. Okay, this is chain approx none and chain approx simple. What I have told you earlier in the video, like this retain all the counterpoint without any approximation, but it have commonly used counter approximation method, and it does not simplify the counter and preserve all original point and make up the counters. It just give all the points, original points. It compress horizontal and vertical and diagonal segments and leave only the end point. It just give the end point. Use the We use this method when we want accurate representation of counter. We use this when we want simplified representation or basic shape. uh, it is less efficient in memory and computational compared to chain approx, cause retain all the points, but it is retain some points, so it's more efficient. Then yeah, moment sorting, approximation, and matching counters. So first of all, what is moment? This is a definition which I know you will not understand any, but I am reading it just for an formality. Moment are a set of scalar that are aggregate of set of vector, and without getting the heavy into the mathematics behind it, thinks of it measure of image intensity. So in short, it is measure of image intensities. An image with pixel intensity Lx, this is the formula. But what is a moment in general? What is a moment? This is a moment of in physics. So what is moment in physics is, if you are a science student, you will know that moment means is like this is the moment we rotate a thing. We are applying force in rotation mode in, and it is rotating, then this have a moment. This have a moment like this. So exactly, this is a moment of force. In physics and engineering, the moment of force, also known as a torque, is measure of tendency of a force to rotate an object around an axis of pi. Then, so how much force we are existing to rotate this? It is called moment or torque. Moment of image. In image processing, the term moment refer to set of mathematical quantity and blah 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 blah. Okay. So these are the things in which we use moment is object recognition, shape analysis, and image processing. And for what moment you should understand is, here by moment we just, you know, here what is the moment? The center. So what is the moment here is centroid, area, and various other moments, but we for here we will consider moment as centroid. Okay, so let's see it in the code. Where is my collab? Yeah. Okay. First step. Oh, okay. Sorry, I just put the wrong name. Our topic is moment sorting and approximation and matching counters. Okay, so I have told you what is moment. Let then we will start sorting with the moment. Let's go with that. I will name it moment. So in this chapter, we will learn about these topic. Sort counter by area, sort by left to right, approximation counters, convex sort. We will sort our areas, and why we want to do is, let me show you. Okay, okay. Here first we load our image. Image equal to cp2.imread and image from this folder. Images. We have image here. After that, we grayscale. Remember what I've told you earlier? Load the image, grade the image, scan the image, make count of the image. Load the image, grade the image, scan the image, make count of the image. Okay, so we load the image, we grade the image, we make count scan of the image, and we made count of the image. For counter, we just made a copy of this as a variable of image, and this is external retrieval mode, and for this retrieval mode, this is a approx none, which tell that it consists of all the, you know, all the points. So what was external retrieval mode is, you know, the one which without any hierarchy, and all only the basic ones, you know, outer ones. So after this, we will print the number of counters. Then we will print the number. We will draw counters. What is draw counter is like I just told you in previous chapter, and I'm telling you again. This is the image on which we have to make counter. This is the list of counters. This that we have to draw, we specify here. This is the color of the counter, and this is the thickness of the counter. So let's see what we get. See, this is the image. We made it scanny. If you can look it, let's make it bigger. Okay, this is the image. This is a scan image. This is the counter. Okay, number of counter are 4. You can see because of scan image how we can make a counter so peacefully, so beautifully. Okay, now let us sort the counter. So first technique of our sorting the counter is by moment. Moment means centroid. So with the area of the centroid, we will sort the counter. Okay. So here we will first make a function get counter area. Okay. In this we will give a parameter counter, which is count list of the counter, and here we will make an empty list. All area equal to empty list. Then for counter in the counters, in this list of counter, uh, area equal to, we will make a variable area which have a function counter area. CNT, which have the area. Okay. So this function just tell the area of the counter. Okay. And it will append in the list. It will take the area and it will append the area. It will take the area, it will append the area. It will take the area, it will append the area. Okay. Then return all the areas. So this is a function which we want. Let's make it run. Now let's load our image. After loading our image, let's split. Yeah, before sorting the areas. Okay. So this is by we are sorting by area. Okay, but we haven't sorted till yet here. So it's just area. This function area which have counters. And where is this counter? Here we have found the counters. So we will give these counters to the list. Okay, we'll activate this function. Then making second. This is a sorted function which consists the list of counters. Above I have told you. And in key, counter area. This is an algorithm which is used to sort the counters. Reverse is true means we will sort it in descending order. Okay. Now we'll print the counter area after sorting. Same area function and sorted counters. Then we will make an loop, for loop for IC enumerate. Okay. Enumerate sorted counters. To enumerate function give us two values, index and value. It is used to open an list, sorry, dictionary, index and value. Okay. So we want values here. First we will use moment function. It will take a value m equal to moment function and a value. Okay. So here cx equal to moment m10 m00. On x-axis we will take 1 and 0. On y-axis we will 1 and 0. This formula came here from it is in PDF. The formula of the moment. Oh, it's mathematical formula. Okay. After this, we'll put the text on the image. Image is, and the string is I+1. Where the axis of the c-axis, x-axis and y-axis, which we have to start. This is a style, and I have told you this things, colors, thickness, and space. And then we will use cv2.draw counters. You know what this draw counter do? Image counters. We have to draw color and thickness. And then finally we use IMSO function to show the counter. Okay, you can see in descending order it have much more area, so it is 1. After that, this area is larger than other two, so this is 2, then this, then 4. So we have sorted our counter in the descending order. Okay, so next we will sort it from left to right, like 1 2, it's left, it's right, 1 2 3 4. Okay, for this we want some functions. Okay, let's take this function. These are the function which we required. First, it give the x coordinate, you know and this threshold at the thing which are counter which are smaller than 10, it does not take that, and it gives just x coordinate, it mathematical formula like this. It give us the x coordinate, and this function just draw the red dot on the on the images, you know pv2 dot moment. It's like same mathematical formula like this. Okay, let's activate this functions. Okay, so yeah, first is loading the image, then is it's like we are opening the array or list, sorry, dictionary. uh this is key, this is value, so making an variable orange, which will use this function. Which function this we have made this above, red dot function. It take an image and count a list. Okay, then wait. Okay, okay, so here we have plotted the counters in the dots. It's like red dot, red dot, red dot. This is a function which we use to make this. So after that, well, let's start sorting. Counter left to right, sorted. Counters key. Okay. For left to right sorting, we use just we want x coordinate. We don't want y coordinate. So using x coordinate, we made this function, and we applied the function here, and enumerate counter left to right here. Okay, sorry. We use the function here as a key. We can in key we can give our self-made function, which is like this. So it will sort according to the function which we have given. Reverse equal to false. Let this I have told you in the above code. Then we will put the text with the according to this code. Let's start. And yeah, what this function does is it's like make a rectangles, and give the coordinate of rectangle in the form of x, y, w, and h. Okay, uh, x is first coordinate, y is first coordinate, y, and this is width, and this is height. Okay, you can see we have sorted in left to right. Okay. So now we have learned how to sort the, sort our counters with the help of moment or centroid, and with the help of function like on the x-axis from left to right. It's like if we use reverse equal to true, then it's right to left. And now it's about second part of our. Okay. So where is this moment and the sorting of approximation done, then it's like, wait, yeah. So these are all the sortings, and I have told you what is moment. Now we will use approx poly dp. What is approx poly dp? Wait, I'll give you the text. Okay, okay. So approx poly dp, we use approx poly dp to find a to define a shape of our image. You will not understand it yet. So let's code it and understand what is polydp. First, let load an image, and so what we have loaded. Okay, so you can see this image. So what will polydp do is just, you know try to plot some lines on this image. It's like this, and this. It's not straight, but it gives the straight lines. Okay. Our first thing what we have to do is grayscale it, load the image, grade the image, scan the image, plot the counters. Although we are not doing can8 because we are giving it thresholding it here. Although you can use scanny also. It's your choice. I have showed you how to use scanny and how to use thresh. Then counter hierarchy, found counters. This is the variable where the image is stored, counters are stored. Sorry, images are stored. Then retrieval list and approx none. Okay, it will give all the points. And then we will copy the image again. Okay. Then for C encounters, X, Y, W, H. I have told you what this function does. We will get X, Y, W, H. So we will plot a rectangle and on the original image. Okay. On the image, I have done several copies so that we can do several other things to do some things. Okay. So first we will plot the rectangles on the original image. Starting at xy coordinate, ending at x plus w means width, all the width, and y plus height means all the height. This is the color. And I have told you what is draw counters function. Let's see first what is the rectangle. Wait. Okay. So these are the counters. You can see we got all the counters. Let plot the rectangles. We have got, you know, yo, we have got all the rectangles here covered in this image. Oh. Now we will apply approx poly function. Wait. For C encounter, We will use accuracy parameters like arc length of the image, see 0.3. You can take other accuracy parameter. This is I have taken. Okay, and approx we'll use approx poly dp function. Here is the image. Here, sorry, here is the counter and accuracy parameter here. And after that, we will use draw counter. Copy approx is give the list, which will use we will use for yeah. Let's plot it. You can see approx poly. Just try to plot here. A straight line here, a straight image. So this is how approx poly worked. Let's see what is convex hull. Okay, convex hull. You should know what is concave convex mirror. Although this image is like so bad, but for concave it just going deep inside, and for convex it's like it's going coming out. Okay, so convex hull is similar to counter approximation, but it is not. Okay, so what is it do is it's like a constellation in the stars. Wait, I will show you. You can see like constellation like this. These are like making some patterns, making some. It's giving the shape, but it's not actually like this. It's giving some shapes, but the original shapes are not like this. Let's okay. Let's see what I meant by this. Okay. First we load the image, then we grade the image, then we show the gray image, then we threshold the image. I've told you so many times these things, and like then we will find the counters, retrieval equal to mode equal to list. What do the retrieval list mode do? Is I will show you again until you will learn it. Wait. Yeah. What does retrieval list do? What does retrieval list do? What does retrieval list do? Okay. Retrieval list all the counters but does not make any hierarchy. Okay. So counter of the hand, image, draw the counters. Till here you can understand well. I have told you many times. After that we will sort the counter by the area. Sorted the area. Okay. What we have done here is wait. Okay. Yeah. Okay. These are the counters. Okay. So we have there will be many small counters and one big counter. It's like this going this. So we have minus the counter with the frame which is largest counter. Okay, we have removed largest counter so that our algorithm should work. Okay, let's see. for scene counter hull equal to cvt.convex hull. We uses our convex hull function. Then we will draw the counters and give the hull, the set of hull, and then just okay. Now you will see how weird shape it gives. you know, see. If we use approx poly, it will give lines like this. See. So it is used to determine the shape of the object. Like this is the shape, outer shape of the object. And our last topic of this chapter is matching the counters. Okay, this video will be of 2 hours or 1.5 hours or 1 hour 45 minutes. So let's go ahead. It's already 1 hour. I can see 1 hour 1 minute. And yeah, it's less city than yesterday or previous video. Okay. So what does it do? CVT.match shapes. As its names recommend, it just matches the shape. Yeah, I have written all the codes previously, cause our previous video just stretched so long, it's got quite boring that I'm writing code again. So I'm just copy and pasting it and like making you understand. It's more speedy way of learning the course. Okay, so let's see what we have done here. First, template. We will read an image. Okay, step by step. We made an variable template, give it an image, and we just see what we have given. So we have given this. After this, we will load our target image. We will name it as target, and after that, what I have told you, make it gray. After graying it, threshold it like okay. Why we are thresholding 2 times? Like first is template, second is target. Target equal to gray. Okay. Then we will find counters in this. Counter hierarchy, find counter, trace 1. Trace 1 is like trace of this. And we use CCOMP mode. What is this? All the counters and arrange in 2 hierarchy. Okay. And then simple. Okay. So this will give us some points. Or means just ending points. Okay. Next. Now we will sort the area and after that we will remove the largest, like what we have done in previous one. The counter which is what I have told you, image outline. We have to remove the image outline counter. Only then we will get the real thing. So sorted counter equal to sorted counter and like reverse in descending. Okay. Here, template counter will be counter 1, second largest counter. First largest counter will be a whole image. This whole image is first counter, and second largest counter is this. First counter is like this, or whole box, and in box this is the first counter. So we'll took the second counter, which is index at 1. Okay, if you don't know what is indexing in Python, so just go and learn Python first, but it's very important. What are you doing till now in my video? If you do not know what is slicing. Okay, uh, it was not in taunting me. It's like just I have care for you. Founders hierarchy. First, we will find a counter in the trace2, which is our target variable. Okay. After this, we will make our for loop. Oh, mhm. Okay. For scene counter, match equal to cv2 dot match shape. This shape, this shape will be match. Um, uh, this function will match our counters. Okay. Uh, First template counter, match shape, counter template, counter method parameter. First is counter template. Counter template is template counter. You know what we have to extract. Next is C for all the counters in the image. This has two image. After that method, matching method, then method parameter. You have to study this about yourself or just use these basic settings. Then print match. If match value is 0, okay, okay. So if match value is greater than this, then closest counter is this. Else there is no closest counter. Okay. CV2, just run the function. Okay. You can see it recognize our counter. So congratulations, our second chapter of today videos has come to end, and now you know how to identify one image from the group of image. This is the basic OpenCV projects, and if you have to do a colored image which have many things, you have to learn computer vision with deep learning, which I will teach you after this playlist got over. I will teach you a TensorFlow after we have got the TensorFlow playlist over. Then I will teach you the computer vision. In that, we will recognize the image at large extent, real life projects. Okay. So until then, let's save this file and jump to our next chapter, which is which is oh, lines, circles, and blob. I like this. Lines, circles, and blob. Oh, sorry, that was not yet. It was just a glitch. Ah, okay, it was my fault. Let's save the file. New notebook. And yeah, I have changes some notebook of previous video and put it in the description of the previous video so that you can be access more like in more detail. Sorry, just got some naked. Ah, yes. So this is line, circle, and blob. Okay. So what will we cover in this lecture is how how hug lines, probably sorry, hue lines, probabilistic hue lines, hue circle, blob detection. These functions we will do in today's in this chapter. Our first step. Let's do our first step. Doing our first step. Okay. So what is line detection? I will write here, or let's leave. I'm not writing it. Everyone knows what is line detection. Line detection is just like this is a line. I should detect it. So we will use first. eh, Wait, we will take an image Sudoku. Then we will use IMSO function, and then gray, and then Kenny. Load the image, grade the image, scanning the image. We are not plotting the counters here, although it's type of counter. We are just plotting the line, which is also kind of, you can assume as counters, but counters only in the form of lines. Okay. And then for lines, we will use a function cvt.how line. Okay. It will contain first image. Okay. After image, it will contain accuracy. It's row accuracy. After row accuracy, it will contain theta accuracy. You should go and Google and search for the row accuracy and theta accuracy. It matters term. I'm not explaining everything because else video will got larger and like it got very larger sometimes like last time. So okay, and this is the threshold point. Okay, and then we have make a function for line in lines, row theta equal to line 0, and like some mathematical formulas, and just after doing this all formula we just created x1 y1 x2 y2. After this whole loop we plot the lines, cv2 dot lines x1 y1 x2 y2, and this thickness 2, and like so the image. Let's see. Okay, this is our the original image. This is our the line detection. You can see how clearly it is detecting line. So smooth. I give it full number. Okay, after this we will use other thing, probabilistic view lines. It is very good, but it take high computational high computational complexity. So to to load them, we use probabilistic hue lines. First take image, then gray the image, then canny the image, then use hue line, same edges, accuracy, it is row accuracy, this is theta accuracy, and Uh, yeah. This is theta accuracy. This is minimum line length. This is maximum line gap, and yeah, this is threshold, minimum line length, maximum line gap. Okay. Window line dot shapes, 4x in range, 0 to length of lines. Just print plotting the lines. X1, Y1, X2, Y2 in lines. We plot X1, Y1, X2, Y2 in lines and just plot the images. Let's see. Okay. It is less computationally complex, but it's like a poop. Oh, so weird. That's why I prefer this, but its complexity is so high. Okay, so these was two line algorithms which we use is, and now we jump to the circle detection. Let's detect the circle. Okay, this is the function which you use for circle detection. These are the parameters which I will show you while writing the code. So first, for the circle detection, we want the image of circle. Let's see some circle. Images of circles. Hmm, I'm not seeing any good image. If you have seen the image with a lot of circle, then take it. I've got an image which I've got from my teacher. Okay, let's load the image. After loading, let's see the image. Okay, so these are the image with the many circles. What we do? What we do? We grade the image. Then we could can it or threshold it. But I'm just doing gray, blurring it, medium blur, because it's so clear. It does not need canny blur. We can do canny. It's like it give more, more of. It's like what a value. But I think this function does not contain the black and white image. Although I will make sure it. Although okay, forget it. You can do canny. Make it canny. I just don't know why writing this code I didn't include canny image here. But let's oh okay. So first we had done gray, we had done blur, then we have used cv house circle. First we have given the image blur, then what is hue gradient here? Okay, so this is the method, and currently this is only available for you. Sorry, you have to use this only. Okay, then inverse ratio, and you know you can use different parameter here. I have given it radius. Let's okay. So first we select a circle. Okay. First we took the outer circles. No, then we took the mid value of the circles, and yeah, for in circles, we draw the outer circles, we draw the center of the circles. This is outer circle, CV2 dot circle, and inner circle. So let's see how the image is. Oh, it just made me remember my girlfriend. Just kidding, guys. Don't report me for this. Uh, okay, so this was what is circle detection in OpenCV. And the last topic of this is blob detection. So what is blob? Blob is just anything in our image is like which have different, it says here is color is different and here color is very much bright, or it can see here something, or here it can't see that thing anywhere else in the photo. So these things are in blob detection. I'll mention here. We will use draw key point function, which will take input image, key points, blank output array, color, and flex. Okay, this is our flex. You can use different. Okay, so first read the image and show the image, then detector. We will use a detector which will detect block blobs for our image, and it's like here we will create an simple blob detector as a detector. Okay, so for key points, we have to give key points here. Detector dot detect image, we will give our detector to detect the key points in the image. Then we will make a blank image, and yeah, we'll give an image key point, blank image key point, after that color and flex. Let's make it size big so you can all see clearly. So this is the original one, and our image can see like this is a yellow flower. What is this green inside it? So it think of these are blobs. So it detected these as blobs in yellow flower. What these things are doing here? This is just something just coming out. Okay. So I think this is enough for this lecture. Sorry, this chapter, and just jumping on the next chapter. So let's go. Let's create a new notebook. Let's see what's our next topic. One more time, this animation. Lights, circles, and blob. Okay. Now it's over. Counting circles, ellipses, and finding Waldo. And this is our meme of Waldo. If you don't know, you have played this game, which you have to find this person. This person. Oh, it's not that person. But I want to find this. Okay, leave it. Let's concentrate on counting circle and ellipse first. It's like a small project of finding Waldo. You can add your resume or GitHub, but it's like a very small project. So yes, let's start. We will name it Waldo. Okay. Okay. So first, we will copy. Uh, Downloading our images. Okay, let's guys. Video is quite late, so let's finish fast. Just here we have loaded our image. Okay, this is our image. Okay, let's make a detector. I've already told you what is a detector. Detector is detect the blob. After this, we will make a key point variable which will use detector.detect image. After this, we will make a blob. Yeah, we should make a blank, np.011, and we are ready to make a blob. cv2.draw key points, image, key points, blank, the color, and this is the flag. Number of blob is number of key points. We will add a total number of blocks and put we will use put text to put that number of blobs on the image. Let's paste it. Plot it. Okay. So you can see there are 32 blobs. Oh, but it is plotting the circle, but ellipse also. You can see it. So what I say, city picture or city plotting of blobs. So how should we correct it? We will use parameters, very much parameters. So in parameter, we will use this area. This is area parameter, what it tells. And this is threshold parameter. This is circularity parameter. This is inertia parameter. And this is convexity parameter. Let's use this parameter here. Okay. Just add the parameter. Params, simple blob detector params. Okay. So we will make a detector with a parameters. Filter by area true. Minimum area is 100. Like circularity. This is area above and circularity at third number. Okay, we have written circularity. We have to set convexity, like just give it false and minimum values. What you want me to be add parameter. Okay, okay. So these parameters are in this. Okay, this detector equal to simple blob detector params. Now we will detect the blobs using key point. Data will detect. Now we'll make a red circles. Let's make a green circle. Okay. So this is number blobs. Text. Put text same as before. Let's see. Okay. This is was original image. This is was before parameter. Now you can see circle, 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 circle. 8 blobs. Okay, so we have done the blob section. We have finally done it so fast. Now we will make our finding Waldo project. It's not project, but yeah, project. Waldo. Okay. So first image. Load the image. Okay. I know this is not clear and actually this is no, it's not understandable, but if you crop this thing, wait, I'll show you. Yeah. So if you crop this thing and find it, then this is like how it is. Or you can find this person in this image. Where is he? Let's find it. Where is he? Where is he? Where is he? I think here's it is him. Okay. Let's make a write a code. First step, create image. Second, load a template. Template is this one. You know. Then match template function and some algorithms of min max lock memory. This is a mathematical mathematical numerical things. Okay. Now bottom right. Okay. These are some maths. Like we have just tell him what is bottom right and what is top left. Then we have to just plot the rectangle. We have made it gray, use template, then result, gray and template. This is the image. This is a template, and which we have just opened the min max lock of result. Then we have find min value, max value, min lock, and max lock. Then for top left, we have used max lock, and for bottom right, we have done the things. After that, we have found him. He is here. Here he is. Okay. So this is all about that chapter, and we have completed this chapter in 10 minutes. So yes, we are fast as lightning, my queen, and just save it and new notebook. Okay. What's next? Corner detections. So what is corners? This is corner, this is corner, this is corner, this is corner, this is corner. Exactly, this is corner, this is corner. So in corner detection, we have to do only detect corners. This is quite easy. It does not have any concepts to explain. You already know what is corner detection. Okay. We will use two algorithms to solve this corners uh, algorithms. First is Harris corner detection. Harris corner detection. Okay. Yeah. First, we will load our image and make it gray. Okay. Remember, our corner Harris function require np.float32. So we have to typecast it. Okay. After we typecast it, just now, yeah, I should have give you the parameter weight. Okay. So these are the parameters. Okay. First is input image, block size, kernel size, has director free parameter, and last is output array location. Okay. Okay. So we have used input image as gray, block size as 3, k size as 3, and has detector free parameter equation as 0.05. Okay. Okay. So to enlarge the corner point, what we will use, in last video I have told you about what is dilation. Okay. So in short, I will tell you what is dilation again. Yeah. So this is dilation, increasing the boundary of the corner. Okay. So we will perform dilation here. Wait. Let's make a kernel and use dilation. Okay. So we have dilated the corner so that our algorithm would work more good. Now let's threshold the image for accurate values and just IMSO function. Okay. You can see that we have detected all the corners, right? Okay. But you can see that we have not covered these corners in this algorithm. So we have one more algorithm which is called, yeah, good feature to track. Good feature to track, nice name, no? Let's just Okay. Import the image, make the image gray. Is like corners. For in corners, we will add function cv2.getFeatures to track. In input image, we will give an 8-bit in floating 32 bits input image. Maximum corners and quality level and minimum distance. Okay. Now let's plot this for corner and corners. Wait. X and y equal to corner 0. Corner 0 key. We will plot x y coordinate of corner 0 and convert x and y into int. Then we will plot in the rectangles of the image, x minus 10, y minus 10, x plus 10, y plus 10. So it will like this, it will plot. And let's finally use IMSO function. We should use it outside the loop. Okay, so you can see we have found all the corners. Some are left here, but it's more good than this because it does not cover this. And this algorithm plot itself. Here we have to use receive two dot rectangle. So this is how you can plot the corners. And here chapter ends. Just change the name which I forgot. And corners. I will give you this PPT. Sorry, PPT codes on the GitHub, and link. I will add the link in the description. So that's all for today's video. In the next video, we will cover the okay hard cascade classifier, what it is, how to do it. It's generally of 1 hour or something. So we will do it in next video. For then, it's like that's all. And if you like this video, please subscribe. And that's all for today's video. So thank you for watching till last. Good night.